I have two trigonometric equations for you. And I'm going to be solving these in the interval from closed 0 to open 2 pi, meaning everything including 0, but not including 2 pi, but everything in between. So the first one I have here on the left hand side is 2 times the sine of x minus 1 equals 0. And the way we want to do this is to find all values of x that satisfy the interval 0 to 2 pi. Now, let's talk about the rules of solving trigonometric equations. First, you don't want to divide out, because you will potentially lose solutions. And second is work with one side. Don't mess with anything. But the goal is to isolate the trigonometric ratio. So first, we can isolate this 2 sine x by just adding 1 to both sides. That becomes 2 sine x equals 1. Then we divide by 2. So that's sine of x equals 1/2. We're almost done. Now I'm going to take the inverse sine of both sides. If you don't know what that is, the inverse sine, not sine to the minus 1, the inverse sine is a function that says, give me a ratio value, I'll give you the angle. You'll also sometimes see it as arc sine. These two mean the same thing, but I'll be using them both in my videos. So we take the inverse sine of both sides. That's sine inverse of the sine of x. Sine inverse sine of x is equal to sine inverse of 1/2. Now, these two will basically cancel out, and then you have x equals sine inverse of 1/2. Now, we're looking for answers that satisfy the conditions 0 to 2 pi. And there should only be 2 answers in there. So, I'm going to draw a rough unit circle on this side.
I made a very, very bad trigonometric boo-boo here. Yeah, I was trying to show visually what the inverse sine means, and I drew a bunch of triangles, and I kept screwing up. So, quick warning here, this is a very rough cut right here in this spot. Actually, what I tried to say was that the inverse sine of 1/2 is actually pi over 6 and 5 pi over 6. But it was just getting too complicated for me. I'll explain it again nicely in another video in the future.
And on the other side, 5 pi over 6. I won't mess up anymore. So x is actually the set pi over 6 and 5 pi over 6. I can spend too much time trying to figure out a good way to explain it, but it's not going to happen anytime soon. So here's another one we have here. Sine of x plus the square root of 2 is equal to minus sine x. Now, another thing you want to do is to collect like terms onto one side. So we can subtract the sine from both sides. So that gives us the square root of 2 is equal to 2 minus sines. 2 minus 2 sine x. You can divide divide both sides by -2. You get minus square root 2 over 2 is equal to the sine of x. On the unit circle, this corresponds to which angle? Pi over 4? Well, not pi over 4 because the signs are negative. It's going to be 5 and 7 pi over 4. So after taking the arc sine of both sides, arc sine of minus square root 2 over 2 is equal to the set 5 pi over 4 and 7 pi over 4. Now there's one more I want to do, and it will show a trick that I always use whenever I have some powers, some like powers and like ratios in equations. It's going to take up the entire board. So Okay. We have this one. It's going to be 4 sine cubed of x plus 2 sine squared x plus 2, minus 2. It's going to be minus 2 sine x minus 1 equals 0. Now this looks really daunting. You say, how would you do that? The site I got this problem from recommends one way, but here's another way you look at it. You see that these are in descending powers. So, and it kind of looks like a polynomial, and in fact it will turn into a polynomial if you do one thing. If you ever have a problem like this, I always find it easy to use substitute, which means take the ratio and set it equal to a variable. It could be u, v, whatever, but u is a common variable to use, so I'll just use it. So we'll set u to be equal to the sine of x. Now this next thing I'm going to do will make the final answer easy. It's going to be, if we take the arc sine of both sides, we're going to get sine inverse of u. And remember, sine inverse and arc sine and inverse sine all mean the same thing. Sine inverse of u equals x. So we can rewrite this entire equation by replacing every sine with u. It's going to be 4u cubed plus 2 sine squared, 2u squared minus 2u minus 1 equals 0. And now, if you haven't watched my videos on polynomials, you can go right ahead and go click the annotation link. Now, this one is going to be very easy to do. First, I'll use the rational zero theorem to figure out possible candidate zeros. You're going to have plus and minus 1, because that's the p right there. And then your cube is 4, so you're going to have plus and minus 1/2, and plus and minus 1/4. Those are your candidate zeros. I'm not going to do Descartes' rule of sines. You can figure out possible number and nature of roots. So I'm going to start off with 1/4, because I kind of like the look at that. So put 1/4 into our synthetic division box. It's going to be 4, 2, minus 1. Bring down the 4. 4 times 1/4 is 1, and 2 plus 1 is 3. 3 times 1/4 is 3/4. Now we can already tell we're kind of not going to get a good 0. But let's just finish it out anyway. Minus 2 plus 3/4, that's going to be minus 1 1/4, or minus 5/4. And minus 5/4 times 1/4 is net minus 5/16. We can already tell we didn't get 0 here, so 1/4 isn't a root. So let's erase that. 1/4 isn't a root. And I'm going to try negative 1/2. So I'm going to put down the same numbers again. 4, 2, negative 1. Alright, here we are. Bring down the 4. 4 times minus 1/2 is minus 2. 2 minus 2 is 0. 0 times minus 1/2 is 0. Minus 2 plus 0 is minus 2. And minus 2 times minus 1/2 is 1. Minus 1 plus 1 is 0. We got a 0. Therefore, this is a 0. This is a root of this equation. So I'll just put that off to the side. Minus 1, u equals minus 1/2. So now we're going to convert this into quadratic. So that's going to be 4u squared minus 2 equals 0. Well, we can add 2 to both sides, so that gets us 4u squared equals 2. And divide both sides by 4. U squared is equal to 2 over 4, or 1/2. Then I take the square root of both sides with both signs, plus and minus. So u is equal to the square root of plus is actually equal to plus or minus the square root of 1/2, which simplifies down to plus or minus square root 2 over 2. And those are our 3 answers for u. Now that we have a u, we can actually take the inverse sine of each of those. We can take the inverse sine and find our answers, our angle values. Because in our original problem here, we're finding angles. Here, we just found u's, which correspond to the values of the ratio. So, inverse sine of minus 1/2 is equal to, well, from the unit circle, it's going to be 7 pi over 6 and 11 pi over 6. Remember, we're still solving in the interval of 0 to 2 pi. Still solving in that interval. Alright, if we take sine inverse of square root 2 over 2, the plus, we get pi over 4 and 3 pi over 4. Sine inverse of the minus square root 2 over 2, we get 5 pi over 4 and 7 pi over 4. So this would be all of our x's. So x would be the set. I'm going to list these in order on the unit circle going counterclockwise from 0. Our answers are pi over 4, 3 pi over 4. Let's see, what comes next? 7 pi over 6. 5 pi over 4. 7 pi over 4. And 11 pi over 6. And those are all our answers. I pretty much went over the limit here. So I'm out of time, and I'll see you next time.